Hello everyone and welcome to our third video of the series discussing data analysis and machine learning for water treatment and desalination. In the last video, we discussed the supervised machine learning and also we implemented a machine learning model to predict the pressure drop from the data coming from pilot plant or filtration system in water treatment and salination application. In this video, we are going to know which feature in our data has a major influence on pressure drop, or in other words, which feature was the most important one to predict pressure drop using our machine learning model. And we are going to do that by a class called model feature importances. Let's do that. In this graph, actually, we have all features in our data except pressure drop on y-axis, like permeate flow rate, recovery, VTDS, salinity, and temperature. And on y-axis, we have something called importance score. This score, which is from 0 to 1, shows the importance of each feature in our data. Like here, feed salinity has a score of 0.99, which means that feed salinity is the most important feature in our data. Or in other words, feed salinity has a major influence on pressure drop. In order to show that, and also in order to use our machine learning model to predict a pressure drop from a new data, we will create a new data. Suppose we have a new data coming from the pilot plant, and or we are going to operate our pilot plant with like feed flow rate of 500 cubic meter per hour, and our feed salinity is 10 gram per liter, and our temperature as was like is 25, and we wanted to know what will be the pressure drop if we run this the plant or pilot plant with this or those operation conditions. So here, our new data, as I just mentioned, like feed flow rate, salinity, 10 gram per liter, and we don't know yet what is the value of pressure drop. So it's zero. So we don't know yet. We will predict it by machine learning. So we will fit or we will give our new data to our machine learning model, and now we will see what will be the pressure drop. So as you can see, the predicted pressure drop from this data is around 1.3 bar. Now let's change or adjust our data and to see like what is the impact of changing or adjusting operation conditions on pressure drop. And we are going to change or adjust feed salinity, which we already knew that it has like a major influence on pressure drop. So let's do that. So we will change it to be 20 and we'll see what will happen. Let's run this cell. Here, like feed salinity has been changed to be 20 gram per liter. Let's see what will happen to the pressure drop. As you can see, we have like an increase in predicted pressure drop when we increased a feed salinity. Let's decrease feed salinity to be 5 gram per liter and see what will happen. So let's run this cell and let's see what will. So now, as you can see, the pressure drop decreased from around 2.3 bar to around 0.9, which means that like the feed salinity had a major influence on pressure drop.